Hello friends and welcome to TMaths. Today we're going to solve simultaneous differential equations using Laplace transform. So for this example we are asked to find the value of x and y with initial conditions x not is 0, y not is 0. And we're going to do this by applying this theorem we already learned. But first of all, let us just put down this. Let Laplace transform of y be y of x, and the Laplace transform of x be capital X of x. So with that being established, we'll find Laplace transform of each of those equations. So y derivative minus x is equals to the Laplace transform of et. And for the second equation, we have that the Laplace transform of x derivative plus y equals to the Laplace of e minus t. And this will give us, by linearity, y prime minus the Laplace transform of x. Simply, Laplace transform of e to the t is 1 over s minus 1. And the second part, by linearity, Laplace transform of derivative of x plus Laplace transform of y, this will give us 1 over s plus t. So if we solve this, we're going to get that to be s Laplace transform of y minus y naught. Let me write this better. Minus y naught, then minus the Laplace transform of x, and this will still give us 1 over s minus 1. And for the second equation, we have s Laplace transform of x minus x naught plus the Laplace transform of y equals to 1 over s plus 1. And we know this is 0 and this is also 0 from our initial conditions. So with that, we'll write this whole expression. This will give us s y of x minus x of x. This is 1 over s minus 1, and then s x of x minus plus y of x give us 1 over s plus 1. And we are looking, so to solve this, we have to either solve for y of x or x of x. And to do this, so for the first one, let's try and solve for y of x. Okay, and we can do this by multiplying this equation by x. And if we do that, we're going to have, for this first equation, it will be s squared y of x minus x of x. This will give us s over s minus 1. And the second equation is just what it is, s x of x plus y of x being equals to 1 over s plus 1. So if we add these two equations, just addition, we're gonna see that what we're gonna have left will be s squared y of x, this 2 minus x of x. We add this side, and then we add this side on the equal sign, then plus x of x plus y of x. This will be equals to s over s minus 1 plus 1 over x plus 1. And this 2 will just give us 0. Okay, so what we're going to have at the end of the day is s squared y of x plus y of x, and this is going to be equals to s squared plus 2x minus 1 all over s minus 1 s plus 1. And if we pick like terms here, this is just going to give us s squared plus 1 y of x. This will be equals to all of this, s squared plus 2x minus 1 over s minus 1 s plus 1. And if we divide through by x squared plus 1, we'll have that our y of x will simply be s squared plus 2x minus 1 all over s squared plus 1 s minus 1 s plus 1. And remember, our partial fraction will want this to be in this form: a plus bx over s squared plus 1 plus c all over x minus 1 plus d all over x plus 1. Okay, and if we divide, if we take these two, if you take this and divide both sides by this denominator here, we're going to have that our s squared plus 2x minus 1 will simply give us a plus b s minus 1 s plus 1 plus c s squared plus 1 s plus 1 then plus d into s squared plus 1 s minus 1. And we are now trying to find those values, the values of a, b, c, and d. And to do that, to pick a certain s that will help us solve this, we can look for an x that will give us a 0. So for here, if we set s to be 1, this whole thing will be 0. So we'll pick such an x. So we'll start by saying let s be equals to 1. And if we do that, the right hand side, we're just going to give us 2. This is just going to give us 2 if s is 1. And for this term, this is 0 and this is 0. So all we have left is this term. And if s is 1, we're going to have c into x being 1, you're going to have 2, which will imply that our c is just going to be 1 over 2. Alright, so our c is simply 1 over 2. And I'm going to easily wipe this. Let this be a little bit clearer. Okay, good. So the next x we're going to pick, you see, if we set out for this is x plus 1. So if we set s here to be negative 1, this will give us 0. So, and that's what we were looking for, things that will simplify the whole expression. So if s is negative 1, this side we're going to have 1 minus 2 minus 1. So this is good. So this is going to give us negative 2, and this will be equals to, if s is negative 1, this will be 0 and this will be 0. No, sorry, please, this will not be 0, please, guys. If s is negative 1, this will be 0 and this will be 0. So all we have left is this term. So we have our d into 2 negative 2. Alright, so which implies that our d is equals to negative 2 over negative 4, which is 1 over 2. So we have our c and we have the value of our d here. It's left for us to find our a and b at this point. So we can do yet another thing and say let s be equals to 0. And if that's the case, the right hand side is going to give us negative 1. And if s is 0, we're going to have a here. Oh, we made it slight. This data, that's an s here, please. Okay, I skipped it. Sorry, guys. So, because we have it here, bs. Okay, so if s is 0, you can see that this will be 0, so we're going to have a into -1 and 1 plus c into 1 1 plus d into 1 -1. And we know the value of c and the value of d, and if you solve this out, you'll find out that your a is simply going to be equals to 1. And then if you pick any other term, say s equals to 2, and solve it yourself, you realize that your b is actually -1. So b here will just give you -1. You have to solve this yourself. Just put it 2 here. You have the values of a and c and d. You find your b. And with this being said, you can now write your y of x, which we know to be this. This is y of x. So if we write this, we're going to get that 1 minus s over s squared plus 1, then plus 1 over 2 into 1 over x minus 1 plus 1 over 2 into 1 over x plus 1. So to find out y, we know that y is the Laplace inverse of y of x, and that would be the Laplace inverse of, we can separate this will just give us 1 over s squared plus 1 minus s over s squared plus 1 plus 1 over 2 1 over x minus 1 plus 1 over 2 1 over s plus 1. And if you distribute the Laplace in this Laplace inverse, so if you distribute that within the bracket, you're just going to find out this is going to give you, the first term is going to give you what? That's sine t minus cos t, because a here is 1, then plus 1 over 2 exponential t plus 1 over 2 exponential negative t. And this is the value of your y. So to find out x, we'll put back the same equation, but for here we just multiply this term by 1 and this by negative x. And if we do so, this is going to give us s into y of x minus x into x. This will give us 1 over s minus 1. Second part will give us s squared x of x, okay, this is a minus here, minus sy of x, and this is going to be equals to negative x over s plus 1. So we're going to add these two equations, and if we do so, we're going to have sy of x minus x of x minus s squared x of x minus x y of x, and this will be equals to 1 over s minus 1 minus x over x plus 1. And if you look at this, you can clearly see that this minus this will simply give us 0. So what we're going to have left is going to be, and if we substitute x of x, we have negative x of x into 1 minus x into 1 plus x squared, and this is simply going to give us negative s squared plus 2x plus 1 all over x minus 1 s plus 1. And this you can rearrange to be negative into s squared minus 2x minus 1 all over s minus 1 s plus 1. So you see we have a negative sign here, we have a negative sign here. So this can easily cancel each other. Okay, and if we do that and we divide both sides by this, so this is, we have that our x of x is simply going to give us s squared minus 2x minus 1 all over x squared plus 1 over x minus 1 and x plus 1. And this, as we saw for y, we know this, we know we want it to be in this form: a plus b s all over s squared plus 1 plus c over s minus 1 plus d over s plus 1. And then, just as we did for the previous step, we have that our s squared minus 2s minus 1, this is simply equals to a plus b s into s minus 1 s plus 1, then plus c into s squared plus 1 s plus 1 plus d into s squared plus 1 s minus 1. And clearly, if you set your s to be equals to 1, we are going to get that your c will be equals to negative 1 over 2. I can show you that. So if s is 1 here, we're going to have 1 minus 2 minus 1, right? And this is simply negative 2. So this will be negative 2. And this will be equals to, if s is 1, this term will be, this guy will be 0. And this guy will be 0. So all we have left is c. And if s is 1, this is just gonna, s is 1, this is just gonna give us c into 2. 1 squared plus 1 is 2. Then 1 plus 1 is 2. So give us 2. So that implies that negative 2 is equals to 4c. It implies that c is negative 2 over 4, which gives us our negative 1 over 2. So that's how we, so it's just substituting values. And if you do the same for s equals to negative 1, you're going to obtain that your d is going to give you negative 1 over 2. Okay, and if you set s to be equals to 0, you get a to be equals to 1. And if you set s to be any other number, let's say 2, you would definitely obtain that your b is just going to give you 1. Okay, this is just this for you to solve, which is something very interesting. So if you put all this back to find your x of x, which is what we have here, if you put all this back, you're going to have that your x of x is simply going to give you 1 plus s all over s squared plus 1, then minus 1 over 2, 1 s minus 1, and minus 1 over 2, 1 over s plus 1. And as we know, the Laplace that our x is simply Laplace inverse of x of x. Okay, and this is going to give us the Laplace inverse of 1 plus x all over x squared plus 1 minus 1 over 2, 1 over s minus 1 minus 1 over 2, 1 over x squared plus 1. And by linearity, you're going to have that this is equal to Laplace inverse of, let's pick the first term, 1 plus s over s squared plus 1 minus 1 over 2 Laplace inverse of 1 over x minus 1 minus 1 over 2 Laplace inverse of 1 over s plus 1. And if you look at the first term here, this is going to give us same as Laplace inverse of 1 over s squared plus 1 plus s over s squared plus 1. Then, and this is still, and then you have minus 1 over 2 exponential t minus 1 over 2 exponential negative t. And what we'll have here is going to give us Laplace inverse of, by linearity, 1 over x squared plus 1 plus Laplace inverse of s over s squared plus 1 then minus 1 over 2 exponential t minus 1 over 2 exponential negative t. And finally, our x is just going to give us, here we have sine t plus cos t minus 1 over 2 exponential t minus 1 over 2 exponential negative t. And this is the value of your x, this is the value of your y. But then let's do one more thing by verifying if this is actually correct. And we can do this by just substituting the values into our expression. So for the first, we're just going to do it for the first equation. We have y prime. You can do for the second one minus x. This is going to give you e to the t, right? So we have our x here. But then what's our y? Our y is simply our y to be sine t minus cos t and all that. Have our y is sine t minus cos t then plus 1 over 2 et plus 1 over 2 e negative t. So y prime will gonna give us the derivative of each of this, and if you do that, you're gonna have, this will be cos t and this will be negative sine t, so this will be plus sine t, and then derivative of 1 over 2 e exponential t is same as 1 over 2 exponential t, and for this we're going to have negative 1 over 2 exponential negative t. So these are y, so let's y prime, so let's put it back in here in this equation and see if we're going to get e exponential t. We're going to have, so this is cos t plus sine t then plus 1 over 2 exponential t minus 1 over 2 exponential negative t, and then minus x, and these are x, so this will be minus sine t minus cos t, negative will give us plus 1 over 2 et plus 1 over 2 e negative t. Okay, so look at this. This will cancel with this. This will cancel with this to give us 0. What do we have left? Exponential et, exponential et. When you add the two of them, we're going to have, so what we'll have left is 1 over 2 exponential t minus 1 over 2 exponential negative t plus 1 over 2 exponential t then plus 1 over 2 exponential negative t. And if you look at this two, that's still going to cancel each other to give us 0. So what we really have left is just 1 over 2 exponential t plus 1 over 2 exponential t, which is simply 1 exponential t. And this is what we have here. So that means that this our solution is correct. And I'll leave it to you to verify if this is going to work, if this is correct for the second equation, which is this, and this is definitely going to work. So try this out and let me know if it worked for you in the comments. Thank you guys. Please do subscribe, and if you have any questions, drop it in the comments. I'll gladly respond as fast as I can.